Creatine pyruvate combines two molecules that each have legitimate claims on energy metabolism. The problem is that combining them does not produce what the theory predicts. Pyruvic acid, pyruvate in its ionized form, is the endpoint of glycolysis, the process by which glucose is broken down in the cytoplasm. From pyruvate, the cell can do several things: convert it to acetyl-CoA and feed it into the Krebs cycle for aerobic ATP production, convert it to lactate to regenerate NAD+, and sustain glycolysis during high-intensity effort, or use it in gluconeogenesis to synthesize new glucose. Pyruvate is central to carbohydrate metabolism in a way that makes co-delivery with creatine theoretically appealing. You are supporting both the phosphocreatine buffer system and the aerobic energy pathway with a single compound. Pyruvate supplementation has its own independent research history. Studies in the 1990s showed that high-dose pyruvate, typically 30 to 50 grams per day, produced modest improvements in endurance performance and slight reductions in fat mass. These effects were attributed to pyruvate's role in supporting aerobic metabolism and its potential mild thermogenic effect. The doses required were large and practically difficult to maintain, and subsequent research has not consistently replicated the magnitude of the original findings. Creatine pyruvate products typically deliver creatine and pyruvate in a bound form, at doses of 2 to 4 grams per serving. The creatine content, roughly 60% by molecular weight, is lower than monohydrate. The pyruvate content per serving is a small fraction of the 30-plus grams used in pyruvate research that showed performance effects. One published study compared creatine pyruvate to creatine citrate in cyclists. Both groups showed improvements in endurance performance, but the creatine pyruvate group showed slightly better aerobic capacity measures. A second study found creatine pyruvate produced better anaerobic performance than placebo. Neither study included a monohydrate comparator, which is the essential missing control. Without knowing how these outcomes compare to standard monohydrate, the results tell you that creatine pyruvate does something, not that it does more than the simpler alternative. The experts who rarely recommend creatine pyruvate are operating from a straightforward cost-benefit analysis. The evidence for its advantage over monohydrate does not exist. The pyruvate dose delivered is below the threshold where pyruvate alone has shown effects. The cost per creatine gram is higher, the manufacturing complexity is greater. Nothing in the evidence profile justifies choosing it over monohydrate except novelty. For athletes who want to explore pyruvate supplementation as an independent intervention, the appropriate route is to supplement monohydrate alongside separate pyruvate at the doses used in the research literature, which is impractical given the dose sizes required but at least controlled. Creatine pyruvate is an intellectually interesting combination that has not delivered the synergistic outcomes its mechanism predicts. The history of pyruvate research is important context. The studies that established pyruvate as a potential performance aid, primarily work by Ronald Stanko at the University of Pittsburgh in the 1990s, used doses between 25 and 100 grams per day. These doses produced modest but measurable effects on endurance performance and body composition in some studies. They also produced significant gastrointestinal discomfort, bloating, gas, and diarrhea at those quantities. Practical widespread supplementation at these doses was never realistic. The attempts to commercialize pyruvate at lower, more tolerable doses have not consistently replicated the original findings. At doses of 2 to 5 grams per day, the range practical for supplement use, independent research has not found reliable performance benefits. The dose-response curve for pyruvate appears to require quantities that are not compatible with comfortable daily use. Creatine pyruvate products typically deliver less than 2 grams of pyruvate per serving. This is substantially below even the low end of what the pyruvate research used. The compound is delivering a pyruvate dose too small to replicate the pyruvate-specific effects, while simultaneously delivering a creatine dose that is lower per gram of product than monohydrate. It is a compromise that does not fully realize either molecule's potential. Creatine pyruvate is a product that sounds sophisticated enough to justify a premium without the clinical evidence to support it. The correct question is not whether it contains real creatine. It does, but whether the pyruvate addition does anything the monohydrate literature has not already established. It does not at the doses delivered.